I should teach every concept during class and say, okay, do your homework, and then just be done talking to students for the rest of the day. That'd be a good strategy, don't you think? Oh, well, I got that on video. Oh, gosh, I guess I can't do that now. Okay, here is the fourth video in the SP standard, which stands for Statistics and Probability. This is the review series for the Spring 2019 Second Semester Math 3 Final Exam. Remember, as I'm saying, for every one of these videos, and you guys are already tired of hearing it, just like, imagine this is my 27th video. Imagine how tired I am of saying it. This series of videos is not all-inclusive. You are responsible for turning off your phones in class, Alyssa, and for studying for every single concept and everything we've done all year long to review for the final exam. Okay. Here are the questions they're asking you about this histogram. Let's do a little bit of counting on this histogram real quick. Okay, it looks like we've got data spread from 10 up to 49, right? From 10 up to 49. How many in this block, boys and girls? 2. How many in this block? 2. How many in this block? 3. How many in this block? 5. Damn it. How many total data points do we have? 8, 12. Can you count? That's how you count and find out how many total data points. Okay? So the questions become very easy. How many data points? How many data points between 30 and 50? How many are there? There's 8. It's literally that easy. What's the percent between 10 and 20 though? Okay, so I start at 10 and stop there at 20. The percent is going to be 2 divided by 12 or 1 over 6, whatever that percent is. It's like 0.167, I don't know, something like that. And then here's the tough concept question about the histogram. And we had a tough time figuring this out. We went over this on Pearson. If it says the mean is at 32.9, that's about right there. When you're looking at a histogram, you have to calculate the median by counting in from the center. In from the outside. If I know there's 12 data points, then between what 2 data points is my median going to be? It's going to be between data points 6 and 7. So going this way, when do I hit data points 6 and 7? 2, 4, aha! I get up to 7 somewhere in there. So it's going to be somewhere in there, right? What if I count from this way? When do I get between data points 6 and 7? 5, 8. Oh, it's going to be in there somewhere. So how to find the median from a histogram is you take the middle value of that bar. It's supposed to say around 35. That's where the median is supposed to be. Look at what choices you have, though, for this multiple choice. So what do you guys think the answer is? Yeah, it's going to be 32.5 is the only one that could make sense. That's the phrasing right there, could be. Okay? Does all that stuff make sense for how to interpret the data there on the histogram? Okay? That took too long. Let's go real quick. Here I have a data distribution that's normal. The mean is 25 and the standard deviation is 1.5. I think that's what I have on this question. Let me turn the page here. Where is it? Yeah, here it is. Mean is 20, standard deviation of 1.5. Where in the hell did I get this question? I'm sorry, I'm lost, boys and girls. Oh well. I don't know where I got this question, but hey, it's good for us to calculate a z-score. I'm positive I wrote it on there somewhere. Oh well, you're going to hear me screw up on video on YouTube. No big deal. Okay, how do you find the z-score? What is the z-score? Remember, it's just like we did for every calculation. It's the data point, so it's going to be 20 minus the mean. Remember, it's data point minus the mean divided by the standard deviation. You guys remember that? So it's going to be negative 5 divided by 1.5, which is, I don't know what that is. 5 divided by 1.5. 3.3 repeating, negative. So what is the z-score for 3.3 negative repeating? Let's see, where is it? Can you guys see this? 3.33. So the z-score, this is out to 5 decimal spots too, which is cool. So it's 0.0043. What does that number mean? Do you guys remember what that number means? I even say it on the table for you. It's the area under the curve to the left of that z-score. So a score of 20 with a mean of 25 and a standard deviation of 1.5, there's only less than 0.5% of scores to the left of that from this table right here. Last question. What if this distribution mean of 25 and standard deviation of 1.5, what percent of the curve or scores were greater than 26? Well, we've got to do the same thing, except this time it's the data point minus the mean over the standard deviation. So this is 1 divided by 1.5, which I don't know what that is. Should be 0.67. Where's our 0.67 positive? 0.67. Right there? 0.74857. 0.74857, right? So the z-score is 0.74857. Isn't that the area to the left? They're asking for what area, what percent scores got above 26. So how do I interpret this based on this right here? You guys remember? 1 minus 0.74857. And then convert that to a decimal. 1 minus 0.74857. So it's going to be about 25% got greater than a 26. Okay? That's all for that video. Wow, that was 7 minutes.